Welcome to Future Forward, a podcast where we share AI insights, one expert at a time. I'll be talking to experts from various backgrounds, ranging from academia to startups, scale-ups, and corporates. Welcome. Hi there, I'm here with Wouter Denayer, former CTO of IBM Belgium and currently tech advisor for investors, family offices, private equity companies, VCs, all around, working for, amongst others, Summa Equity. Hi Wouter, how are you?
I'm great, Davio. So fantastic to be here and to have this conversation.
Welcome. Maybe to kick off, you have a past in AI. You're not just new now that the hype or the trend is here. Tell me a bit more. How have you seen AI in the past and how have you seen it evolve?
Yeah, it does go a bit way back, I would say. I started my first encounter with AI was maybe in '93 already, when I did a postgraduate degree at University of Ghent. Back in the day, I can almost say now, AI was different. It was...
no deep learning and transformers yet, probably?
No, not at all, not at all. It's what we now call good old-fashioned AI. And it was mostly based on symbolic approach, so where you manipulate symbols. Just think about a chessboard. So the symbols are your chess pieces, and the rules are whatever moves are allowed on the board. And then we would think about expert systems, maybe an expert chess player that would be very good at moving those pieces on the board to win the game.
Yeah.
And that's the way that we thought about
So it's
AI
basically
at
a
the time.
decision tree that you write out.
You could say that there are rules that can be applied, and then the thing is to smartly find those rules that apply in the best context. That was the main thing at the time around AI, symbolic AI.
And that's just past the second, let's say, what they call summer of AI, which was during the 80s in the expert systems?
Yeah, totally. A bit after that, effectively. There was a bit of interest, but still then there was no commercial application, I would say. I had a class by one entrepreneur who had a company in AI. He wanted to do, I think, predictive maintenance on...
Already 30 years ago.
Yeah, absolutely, using AI, but the business didn't take off. I think the approaches were not mature. The models did clearly not scale. Because we did have neural networks already back then, but they were very small and...
So not enough compute, and therefore they were small? Or they didn't understand yet that size could have mattered?
I think they understood, but they had not found yet a way to train large models. So the whole concept, as you know, backpropagation, right? The famous mechanism, how do you train a neural network?
Yeah, so basically feeding it, asking it if it's correct, and then going back and adapting the weights.
So exactly.
Until you have something that predicts what you want to predict.
So that approach existed from the 60s.
Okay.
However, it did not work for large networks. There are all kinds of problems through which they could not train larger networks. And this only got fixed much later, maybe 2010.
Okay.
So that's kind of the gap.
Just before when we saw AlexNet and ImageNet competition and the first breakthrough of deep learning, actually.
Yeah, and AlexNet was one of the first in 2012 to win the image competition using convolutional neural networks, and they used new approaches to train the neural networks. It was still backpropagation with some fine-tuning. We shouldn't go into that right now, but that was a big breakthrough at the time. So I learned about neural networks, I learned about expert systems, I learned about genetic algorithms where you use like the concepts of evolution and survival of the fittest. And so all these approaches were there in parallel. It's still what they call the tribes of AI, so different approaches of AI. And so now today we only have our eye on generative AI, which is a subclass of neural networks, which is only one of the different approaches in AI. But there are more approaches. And so one of the things I tell clients about is, hey, you should not focus only on Gen AI because there's this whole set of other ways to solve problems, which are sometimes easier, more explainable, use less compute, and so we should not forget those approaches. And I think many new entrants, many people that are new in the field, they focus only on the generative AI part.
Yeah, definitely. But what you typically see is the older systems are more within the sphere of narrow AI, that they're very good at one particular thing, but that's the only thing that they can do. So they're very good, but their applicability is not very wide.
Yeah.
And generative AI is basically almost the opposite. It's very wide, but it's not very capable in a lot of things. But the way I look at it, because often we get in the question, okay, but when do we use what? So the way I look at it today, and it's not been tested, it's just an idea. The generative AI and the more LLM and transformer approach, so the broad capable things, which are slowly improving, I see them more as like they're put out right now, co-pilots, more as virtual colleagues, or if you will, virtual, not in the virtual sense like we're used to now, but a digital twin kind of thing.
No.
So it's supporting people, but then the narrow AI, I see that more as in improving machines, actually, because you typically see that, for instance, detecting a default in a manufacturing process, it's actually not something that a human does. It's a machine. It's just getting better at that. So that's maybe an oversimplification, but how do you deal with that if people ask? Because it's a very, are there easy ways to think of how can I, if I have this wide choice of AI algorithms, when can I use what?
No.
I have a bit of this system, but it's not necessarily...
Yeah, sure. I think the older approaches, the traditional, it's funny that we say that, the traditional AI approaches indeed are narrow AI. Now, many problems are narrow, right? In many cases, we know where we want to apply the AI system to do a prediction. It's always a prediction. Like if you want to do a time series prediction, you do not need a generative AI system. So I think that's, for me, the rule is smaller is better.
Well, on that part, we touched upon it briefly at Supernova, the time series and GPT. We actually, I told you, my colleagues were writing a blog post. It's actually already online, and what you see, the analysis, it's not on par with actually the narrow AI part. But what you do see is if you don't have a lot of data, it actually is already quite good. Yeah. It's not bad at it.
No, totally. Yeah. So I think one of the big advantages of generative AI is you can start with when you have almost no data, right? And that is amazing, because in the past, the biggest blocker often was, I need a lot of data, exactly. I do not have the data. And so by the time companies wanted to start to use it, they noticed that they didn't have the data and had to start to collect, and then you lose 2-3 years before you have it. Yeah. So with Gen AI, we can start quickly, also indeed with time series. It's still better to have a real data set which is specialized, and then you can use the traditional AI mechanisms. And then also we see the trend with Gen AI that even there, specialized models perform better. So if you fine-tune a generic model, if you take GPT-4 and you fine-tune it, you actually specialize it, and then it performs better, but it's no longer as capable in the broad sense. So it's also the same if you start to train your own models, like, for example, TechWolf, what they do for their HR, right? They train their own models on their own data. It's still generative AI. They use an older approach, but it's just very narrow. They know exactly what the vocabulary is. They know exactly what they want to predict, and they can do that at a higher quality than with the generic GPT, because they have the data, because they can train their own model, and they know how to do that. So the quality is better. But the advantage of the generic GPT-4, of course, is it can do anything, right?
And do you truly believe, because what we see in the uses of GPT-4 and Claude and the new models is that actually you have a lot of ways of improving the standard one. It goes from just proper prompting until other approaches for fine-tuning. But it's marginally improving, but the size of the model, like the way that Claude is now improving and what we expect, the steps are a lot bigger, and the advantage of having own data seems to decrease in a certain way. Do you believe that will happen, or do you think there will always be an edge on that?
Yeah, I think For now, who knows, right? But for now, if you have your own data, it will be better because you control, right? We know the famous problem with the hallucinations. Sometimes the AI goes off track. And the more you control the environment and control what is allowed, the least chance that there is to have an hallucination. So I think still specialization is better. Yes, it's true, GPT-4 has this huge data set, but still not everything is covered. Some domains have low appearance in the data set distribution, and so there you get more errors. As if you know what you are doing and what you want to achieve, and if you have the data, I think it's always going to be better. But you can quickly start, right? I mean, you can just start experimenting, see if you have value, and then only do the more difficult work afterwards.
And Ali, it came back in a previous podcast, but actually, I'm a bit. I think we'll see more that the bigger models are going to take over. Like, Bloomberg trained their own GPT. They invested hundreds of millions or 100 million, I don't know exactly. And then GPT-4 came out and it beat it, even though they had specialized data. I think that trend is just very hard to stop. But okay, let's not dive too deep into. You can react, no problem. But I'm just want to go back to the original question, which is basically, how do you advise companies on the difference between like the traditional? What do they choose? How do they?
For me, one important element is explainability. So in some use cases, it's important to be able to explain to either end users or auditors or your own employees why the AI system proposes something, why it predicts something.
Yep.
And this is vastly easier with traditional AI approaches and virtually impossible today with the Gen AI.
Yep.
So this is a big one, I think. So if you can get away with a smaller model, you have higher chance to achieve explainability. It's also probably going to cost you less if you have to run the model at scale. The compute is immense for large language models. We know that. The energy cost is immense. And so if you can do it with traditional techniques, it's explainable, it's probably faster, it's costing you less. So these are, I think, advantages to make sure that your team also understands the other approaches. Because now what you see is you see companies, they really start with Gen AI, and this is where the pressure is and a lot of value is. But the people that are learning that not necessarily have a background in data science. They learn how to prompt and how to connect to the OpenAI API, right, which is the developer can do. But then they don't know all these other techniques, and I think you're sometimes missing opportunities that you could leverage. So yes, by all means, start with GPT and include it in your product, call the APIs, but then broaden your horizon, right? I mean, have these people follow some trainings, at least that they are aware of these other techniques, because they remain valuable. Otherwise, we have the age-old phenomenon in IT that, or the hammer and the nail, right? It's so Gen AI is our hammer, and so now everything is a nail.
Yeah, definitely. It's also very, it's a big challenge because they all want Gen AI, and if you come up with something else, they're like, no, we want that. So it's we were talking about how you've seen it move from the expert systems to AlexNet, and then now you see Gen AI. How do you see it moving forward? What do you see today? So you're mainly advising right now. What's the challenges that you see today?
But the challenge already is with implementing what we have today, right? It's easier to do a hello world or to type your hello world prompt than to integrate this at scale in your software product. If you have a SaaS company, everybody's asking themselves now, where are the use cases where I can make life easier for my end users, speed up some things or offer new features. This is great. In practice, it takes a lot of plumbing, as we call it, a lot of software around the API call to actually make that work at scale. There are scalability issues. You need to get access to enough GPU power. Even with OpenAI, if you use it through Azure, for example, you have to request access in a certain geography. Maybe you are globally active, so you need in different geographies. Maybe your data of your users cannot exit the European Union, so you cannot call a GPT in a US data center. Maybe the system is not always available. Maybe the response times are slow in some cases. So there are all kinds of things in software that you have to do to call the API and get your answer. Then there is the whole element of how do I shape my prompt? What happens when OpenAI releases a new version? Does my prompt still work? And so there is a lot of things that people don't realize and that come into play when you go beyond chatting on ChatGPT. When you incorporate in your product many things you have to do on the technical side. And then there are many things you need to do on the legal side, for example. So next to the technical elements, integration takes a lot of work, right? Engineering work. It's not all automatic. The AI is not yet doing that for you. And next to that, there are other elements that you need to incorporate in your business. For example, legal aspects. If I start to generate stuff in my SaaS application, summaries, lists, all kinds of things. What is the impact to the user? Who is liable if the summary is not correct?
And that's your work today that you do mainly as an advisor, or?
So that's one of the things I do is help create a roadmap, and the roadmap includes, where do I have to be compliant? What do I have to think about in terms of risks? And that's why we work with an AI risk registry. It's basically like, did you think about this? Did you think about that? Is your contracts okay? Do you have an insurance if something goes wrong?
And you're preparing that already towards the AI Act? You're taking that into account?
The AI Act, there are other things like the NIST in US,
What's that?
The National Institute of Standards, I think, in the US, which has a risk management framework for AI. There is an ISO 42001, which is coming into play when people go the next step, not yet today, but some already want to prepare.
What are some of the big things that you see there that we need to be aware of then, to be in those, to work according to those frameworks?
Yeah, it's typical ISO standards, right? They say here are a number of controls, and these are, I would say, obvious, but the ISOs help us be complete. So. Do you think about data privacy? Do you validate the output of an AI-generated system? Do you have human in the loop in your system? Did you think about the impact, physical harm? Is that something that is in your? Maybe not if you have just a SaaS software, but yes, if you're controlling a robot. And so the ISOs just help us to be very complete and explicit and go through that. And make sure that we cover our bases. In some cases, we say, okay, this point is not relevant for what we are doing here. In other cases, we say, oh, we did not think about this. We need to talk to our lawyer because our contract with our client has to be changed.
So basically, you're helping those investors to get a view on all the different risks in their portfolio companies related to AI.
Yeah, and what needs to be done over time, let's say a 2 to 3 year period. What are some of the projects we can put into play? What would the cost be to get there? Over time, as we know, there will be more pressure on being compliant. The EU, the European Union, will not stop with the AI Act. There will be more things to come, and so.
Anything you can? Do you have?
But we know that they will refine. They will get. We will get more clarity on exactly what they mean and what needs to be done. So a lot of work there, and so we help take a company through all that thinking. First, get them up to speed, AI, where does it come from? Do we have to worry about existential risk? Will humanity be wiped out? It's a topic we love to discuss, Davio, you and me, so we can talk about that later, but just go through that in a very methodical fashion, so that at the end of the project, the team has a roadmap that they can execute, and they know what to do to be ready.
Yeah. Okay. Cool. Nice.
Yeah. So that's one thing I do, and then the other thing I do is a bit deeper, I would say. If you want to invest, and you want to invest typically now in companies that are on the AI train, right? Startups. Like, what does it mean? If I can go to them and analyze and assess what is the value of this AI thing that you have built.
Yeah, and what the questions that we typically get with regards to that is, when is it basically a wrapper, or just we put AI on top of it, but actually we're just having some code around OpenAI's API, or is this actually going to last long enough? Because it's not because it works today, it could be disrupted next week if OpenAI releases something new.
Yeah, that's the big thing. Defensibility is the term, and so what I have built today, maybe with a lot of man hours and a lot of clever engineering, took me a year to build this thing. I'm very proud. And then tomorrow there's an open source project doing the same, right? More or less the same. And so the competitor can just go in, get a crazy acceleration, and build the same thing. A lot happened, very concretely, in AI plumbing, pipelines, data processing. A few years ago, everybody had to build this, in semantic search, using what we now would call the GPTs, right? In OpenAI terminology, you put your documents in, you can do a very clever search, talk to my documents style of thing. 1 year ago, this was high tech. Today it's out of the box. And this goes very quickly. So I have built something, I am proud, I put a lot of engineering, a lot of money. Is it still valuable, and what do we expect? Do we expect it to remain defensible over time? So that's one thing.
How do you approach that? How do you deal with that question? Is it defensible? Is it because basically you need to try and predict what's going to come out, or
So that's one thing. So be aware of where the big trends are in the software. But defensibility typically comes from data that I have that somebody else does not have. So that's, I think, important. And adapting the system to a particular business. So the knowledge of the business and how people think and work and speak and what they need in a certain business, and then using the tools to achieve that, that is deep knowledge of an industry, and that is more defensible. Maybe I have a team of experts that can curate data, that can make sure that the data that I use in my AI is high quality. That is valuable, because you need, again, maybe, right, the GPT by itself can do a lot, but higher quality data, we know, is higher quality output. So if I am sitting on a mountain of high quality data and I have the people that can actually make sure this data set is high value, then I have something that maybe the others do not have.
Yeah. Do you, so I always wonder if so I understand what you mean, but at the same time, it feels like it's very temporary. You have a bit of better data, then you build something which is better, but an incumbent, because of their scale, could say, okay, we want to have this kind of data. We start labeling, literally, and we improve it. How do you see that? Is that moat really defensible in the long term, or do you need to use it to build something else around it, a mechanic that is actually a moat within the market? Let me give an example. If you start using expert, an example, Bert, Netflix recommendation engine, you might have a bit better data, you do better recommendations, but at some point someone else can do that the same way, unless you have enough users that keep on feeding your system, and therefore you can increase that moat. That's where the actual moat is because you're a platform and you have people constantly giving you feedback. But the pure technology side, doesn't really sound as something that will
It's
be...
harder, eh?
Yeah.
It's the commoditization is crazy.
Mm-hmm.
The things we can do today that were rocket science 3 years ago, what I can do on my laptop.
And how do you see the investors reacting to that? Do they... Because I spoke to some as well, and some of them are just saying, okay, unless it's very clear that there's, like you're saying, very deep knowledge involved. For instance, it's in biotech or it's in an industry where you really need to understand the industry. Then we might be interested. But the rest, we AI infrastructure, okay, but everything in between, it's too volatile. It's too, and they just ignore it basically.
Yeah, you need deep industry knowledge again. Back to that, and embedding with the clients. So deep understanding of what the client needs and able to deliver that, and then keep innovating, because things move quickly, of course. And the mode is in data, and if you can get a loop of better and better data by using the feedback from your client. It's like providing recommendations to your clients, and the very simple thumbs up, thumbs down thing. It's a good recommendation or not a good recommendation. And if you do that at scale, you get a lot of valuable feedback from your clients, which you can then feed back into the system, do a fine tuning, and the next version is even better.
Do you think that might be, for instance, something, because OpenAI has released quicker than the rest, ChatGPT. Okay, now on you see a lot of signs that Claude 3 is actually science. Actually, they've tested it, and it's better now than GPT-4. At least their biggest version. Do you think that because they are so quick, those two, that they will increase and it will be impossible to?
So I don't know. So what I see is companies integrating through Azure with OpenAI. Through Azure because they have the enterprise contract, because they trust Microsoft, blah, blah, blah. What Microsoft will do is make it easy for you to switch models. So I develop against a language model. Today, my switch is on OpenAI. I change my switch to Claude 3. It's done, right? Yeah. And so the total commoditization of language models. And where do you go? To your preferred platform provider. And so OpenAI was the king. So who is owning in the future your access to the language model? Maybe it's Microsoft with Azure. And
so you would be betting on Microsoft?
Well, yeah, totally. And or Google. I mean, the big platforms that you go to, where you already have built your software, because they, especially Microsoft, is being cross-model, right? Cross-vendor. They have Mistral in there. I think they have Cohere in there. They have So they are just saying, whatever is the best model of the moment, we provide it, and we make it easy for you to switch, which is a bit difficult now because you have to redo your prompts probably and stuff like that. But just imagine, a few years from now, this problem can be solved. Then who do you talk to? Right? Okay, then OpenAI can do version 5, they're better, okay, I switch it on, and then the other ones are better or cheaper, but especially cheaper maybe, because maybe we get to a point where some things are just good enough and I just want to control cost. As you know, if you do OpenAI calls at scale, it's very expensive. And maybe in some cases, in my business, I can cross-charge to my client, but maybe that's not always the case. So cost is going to be more important at a certain moment when quality is just enough. When I can get away with some sort of quality. Maybe that's just the next version. I'd see that coming very soon. Already now, some prompts they keep on GPT-3 because it's good enough and it's much cheaper. And other things today we have to go to 4 because it's better in things. But so I can see there that cost will be more important for businesses. I think Microsoft is in a fantastic position. Google is doing well now with the new models. We will see.
It's improving.
It's improving. But I think the cloud providers are taking over. Like, why did Mistral? So we are a bit sad, all of us, maybe, that Mistral, the pride of France and Europe in the models, is now also, in Azure.
Yeah. Do you see a future for them?
But they are now one of the models in Azure, right?
Yeah.
So if I'm a company, do I go direct to them? I don't do that, right? I go to my cloud provider because all my other stuff is already there and there's no latency and my billing is there and the trust is there and there's so much more.
I don't need to go through the
AI
whole hassle of working with a small company.
Yeah, exactly. And reliability, and I know who to talk to, and the contracts are okay, and all these things. There's so much more going on to running a business with IT and AI than just the model. The model is this small thingy, right?
So, Mistral.
Yeah, good move, I think, for them, because now at least they are available, on a big platform. But now they are in competition with all the others on the same platform, and then which one do you choose?
So, in the end, you see Microsoft. They will be those big platforms. They will be the ones winning here. Yeah.
Do you disagree? I don't know.
Do I disagree? Predicting the future is, of course, always hard, but I think there is a scenario where you actually end up with 5 big companies, and literally because of the evolution we're getting, they're owning the digital space. Soon they might be owning even the physical space through what is happening in robotics, because the link is there as well. They're the main investors, I figure, and Optimus and all. So. I see a scenario, where, because it's easier for us, one platform, we don't want to have a gazillion companies to address if we can have one. But of course, the power that they will have will be immense. On the other hand, I don't know, I would hope that the open source movement and others commoditize and make it available, not depending on a platform, but the reality is that an enterprise, if they can just buy it at one place, why would you? It's what they
just imagine, right?
Bread and butter.
Just imagine I want to take Llama, which I can just download and use. All the things I have to do in terms of deployment and scalability and security and all the things for me to do to use that.
And even if you have that, you're taking as a person the whole liability as if it goes wrong. But if it is Microsoft, you can point to someone.
That, and I have to I have to find the GPUs in the cloud. I have no optimal utilization for them, maybe, so my cost is higher. Like all these headaches.
Yeah.
And then where are we today? People are experimenting. Nobody really knows, how do I make money with this thing? It's not clear, I think. So there are a lot of experiments going on. Let me add this thing to my product and that thing to my product, and let's see what sticks, what works. But that I want to do as quickly as possible and as easily as possible without having to worry about all these difficult AI infrastructure things.
Yeah.
And maybe if I'm Netflix and I'm huge and I have like a ton of views, maybe then I can think about deploying my own infrastructure, because then it will
or
be
you're
cheaper.
a pharma company and you really, it's something strategic and you have the budget and you have the...
Okay, but for the rest of us... Other than, experimenting and maybe trying it out, but at scale, it's just too much headache. Where do you find a company with an IT team with nothing to do that can?
Yeah, and if you read about it, just because for us it's like you put the model on top of a data center and then you have an API in front of it and you use it, but the trouble they have to go through to make it happen, the engineering effort, I read something not so long ago that there's literally people almost sleeping next to the GPUs because they suddenly fail and then they need to fix that on the moment because they don't want to lose time or valuable euros or dollars because they don't know why it stops. It just suddenly doesn't work anymore. It's true. But at the same time, there's something that I'm hoping that there's because the power concentration will be so huge that it's in a way not healthy either, and that's what I think is a bit of a pity. In Europe, we don't see anything happening there unless regulation, and I hope How do you experience that from an investor point of view? Because I'm assuming it's an assumption that they're already also saying, okay, investing in those foundation models in Europe, it's a bigger hassle. Let's not do that. Do you sense that already?
I'm not working with companies that want to build their own foundation model.
Okay.
I mean, again, the engineering effort, the cost. I mean, this is crazy.
Yeah.
Like how many GPUs did OpenAI use to train GPT-4? It was like 25,000 GPUs or something.
I don't know the number, but
crazy,
it's
crazy numbers. Crazy cost. Like estimates are $80 million to train the thing. Okay? Companies I work with, they want to use. Okay, they want to apply. They want the practical things. They want the output. They want the results. So this is not even a topic, I think. And then on the regulation, I'm not so negative about regulation because it gives a level playing field for starters already in Europe. If I comply to the EU AI Act, that means I have no trouble convincing other companies to work with me. It's a stamp of approval that I get by being compliant. It's like having an ISO audit on your development processes, or 9001 or 27001. All these ISOs are there to say, okay, trust us. You know, we've gone through this, and it's the same thing with AI.
I agree with that. In if you look at it from a perspective, you are within Europe, and you ignore the rest of the world. But I don't agree with it if you look at it from a competition point of view, as in the US, China, probably Russia. They're developing those technologies. They're moving extremely fast. They are faster at trying things out because they don't have to comply first with these regulations. And given the speed that it has, the impact on their society will be faster than in ours.
Is that so? So let me question that, because if I look at the EU AI Act, I see, for example, a certain class of use cases is forbidden. So what are we talking about? It's about mass social manipulation of people.
Okay.
So do we want that? I don't want that. So if we can move, if there are companies in Europe that want to move quickly on that, I don't want them to do that.
That's clear.
Okay. So then there are high risk things. They are labeled high risk for a reason. Because there is risk of discrimination. There is risk of social social discrimination and bias. Do I want that in Europe? No, I don't want that. So Europe is. So the point for me is, then at that time we say, okay, we don't want to stop you from doing that, but we would like you to do that in a responsible manner. So that means we put a certain number of controls in place to make sure that you stay within the boundaries that we as society want. But how can we disagree with that?
The bigger challenge that I see is related to the limits they put on top of the foundation models.
Yeah.
They put it, if I think it's 10 to the 25th.
Something flops. Yeah.
I don't know exact number anymore, but basically we're already there, actually, at that point. We can already train those models, and they automatically become a high-risk system as well. And they don't put... but I have a problem with the whole European approach to AI. They put that, and then they don't put an alternative. They don't... Saudi Arabia, which has less money than Europe, GDP, they put 40 billion into AI. Europe, we put a law into AI. It just fundamentally, I don't understand why we're not protecting or really, if we want to move forward, we want to build a better future, we need to invest. We need to innovate. And you feel it's a frustration to me. I can't appreciate it. And then that part, I understand if it has some certain compute, risks might appear, but we don't know which ones there are. Nobody died yet from ChatGPT. There's nothing big happened yet. Okay, not entirely true. I know what you're going to say, but there's no mass problems. We know what these things happen, and that's a whole debate on its own. Because okay, the point that I'm trying to make is, I don't see what risk they are trying to cover, because they don't understand the risk yet, but they put the law on top of it. While if you look at how they do it, the executive order, Biden's executive order is, if you do large compute, let us know, which is a lot more pragmatic. And then if there's problems, you can deal with it because you get a view on them.
Yeah,
how do you look at that?
Yeah, on the large model side, I kind of don't agree. It seems to me it stems from this fear that...
You don't agree with me or with the law?
In this case, I do agree with you, Davio, indeed. because I don't believe in the existential risk of large language model, and it seems a bit that this is where the idea comes from, right? Larger models become potentially sentient and are a danger to society, and so I don't agree with that. So it seems to stem from an unreasonable fear, I think. And why put so much limitations on larger models? The idea is in part that the larger models will be used in many places and therefore have more impact than smaller models, but it seems an undue burden. Why stop ourselves at an arbitrary number of compute flops to train the models where we just want them to be bigger? I mean, they have to be, let's make them 10 times bigger, see what happens. I would I would like to see that, right? So that one I don't really understand, because it seems to me following like the Sam Altman discourse of, the world is going, everybody's going to die and the robots are going to take over and it's existential. I don't see that, so I don't believe that.
And do you believe it will impact the because that's the point where I don't see it's brightly for Europe at this point in terms of AI. I think there's a lot of good things here as well, of course. But do you think that competitivity in Europe will impact it?
So then the question is, would Mistral go over that limit, for example? That's a concrete, right? Will the next Mistral model, whatever, would they go over that compute? Yeah, maybe. I think that's a problem, yeah. They should be able to do that. I think we should regulate on how people use systems and make sure that we put guardrails and that it's responsible and it's not biased. But why put the limitations on the base models? I don't really understand. Yeah.
All right. So yeah, Europe might be having a bit of a challenge there, but it's not lost yet. Let's hope that these initiatives help them to think about it. Now, You've been at IBM. You've seen what happened at Jeopardy. You've told a few stories already. How did you experience that? And what then worked and what didn't work?
Yeah.
Looking at what's happening right now, how do you link those two, and how might you even see this moving forward?
Yeah, it's interesting, and maybe we can learn some lessons. I was indeed at IBM when the famous Jeopardy show was run, right? So the game show, Jeopardy, very known in US, where you get the answer and you have to guess the question. So reverse psychology, I guess. And so IBM built a system which was able to win against the two greatest champions of all time. So the people who had won most games ever, which was quite a feat, because if you remember, before that IBM won chess against Kasparov with Deep Blue, which was another mind-blowing feat. But that was in the symbolic world, it was non-language. And so Jeopardy tackled the aspect of language. Language is complex, language is ambiguous, right? We have double meanings, we have references to cultural stuff. It's hard. Decoding language is very hard. And so what they proved at that point is what they could win a language game, which was another mind-blowing thing. From that, by the way, it was crazy, right? Because the game show was recorded in IBM Research, in the research facility of IBM. So they
not in the original studio.
Not in the original studio.
Why not?
Because it was easier to move and rebuild the studio than to move the computer. So that was the crazy thing. So in Yorktown Heights, IBM Research, I've been there many times. There is a beautiful auditorium. And so they kind of remodeled the auditorium to...
and now we probably have more compute in our pockets than that their whole computer was.
Yeah, probably it's very much possible. But then after that, I think what's interesting, and maybe parallel to today, is IBM used that very cleverly in marketing and said, okay, we are the AI company. I think they were at that time the number one top of mind company.
So they were
right?
IBM. Now then we had Google, and now Microsoft took over.
Yeah, everybody knew about IBM Watson. It was very well known. And then there were big plans to use that technology to go, for example, in healthcare. which was very smart because, okay, a game show you cannot monetize. IBM's commercial company, let's find a domain which is ripe for this kind of tech, because in medicine there's a lot of text. We can analyze the text, we can look at medical reports, we can have diagnosis, all these things. So it makes a lot of sense. But there was a lot of over-promising going on.
But on the back end, or the technology was the symbolic, the expert systems. That's used for Jeopardy, or?
Not really. It was really custom natural language processing, but before the large language models.
Yeah.
So a lot of text processing, very clever search, new ways to search in big databases. Things that were groundbreaking at the time. We wouldn't do it in the same way today. Some principles do remain. But it was all about language. It was not symbolic, really. But the point is the overpromising. And I feel that
it's happening again?
It's happening again.
Okay. So the overpromising was Jeopardy moving to healthcare, but the complexity was a lot bigger probably as well in healthcare, because Jeopardy, it's a game and it's a question.
Yeah.
In healthcare, you can't limit it that easily probably, or there's a lot more just information to process. Yeah. And it failed, or it was just only usable in a few settings, or?
Yeah, I think it was it was successful, like, from my understanding, in a chain of hospitals in US. Memorial Sloan Kettering, where they worked extensively on cancer research. And from that, there were some very interesting results. But what was, for example, very difficult is to take those results and move them to another country, to another system, to another way of thinking. So just taking an AI system and moving it somewhere else is not always so easy. By the way, I think that is still the case today.
Still a challenge, yeah.
Still a challenge. Other languages, less represented languages, Finnish, for example, right, or even Flemish, our problem.
Definitely West Flemish.
Yeah, of course. And so that makes it hard. Culture also is different. The norms are different. The way people think about healthcare, the value of a life, the insurance policies may be different. So the kind of things you propose in terms of treatment are linked to what insurances pay back. So all these things, you cannot just take such a system and just move it.
So the investments to move it are huge then again.
They are
huge. It's basically rebuilding it, as I hear it.
Yeah, and then there was an expectation created, like, we will make enormous breakthroughs in cancer research. And it's an important topic for many people. We all know people that have had cancer. Maybe we lost people from cancer. So it touches us in our heart. And so you create a lot of hope. Which was not IBM not able to fulfill. They invested billions of dollars in data, billions of dollars in data to train models, and in the end, after so many years, Watson Health is no more. And so now today, I find there's in the same spirit a lot of expectation on these large language models and AI. We will all be 5 times more productive, and we will have our personal assistant in our pocket, and we will do this, that, and the other. And I think, and I hope this will happen, but I think a lot of more engineering is needed and a lot more time is needed. And so it will take longer than people think to do these things, to overcome technical hurdles, but also to just adoption, right? Simple adoption in companies. I'm sure you see that, Davio, in your work. You work with companies.
Yeah, but it's true. But at the same time, I wasn't there before, so I can't know. But my impression is it's a bit different in the sense that, take ChatGPT, it's been the fastest adopted new technology ever. Consequence, with a lot of our customers, they already know AI. Okay, to your point, the expectations are often off.
Yeah.
That's true. But the fact that there's already like a mainstream conversation is probably very different than...
Yeah, that's very different than even a few years ago.
Yeah.
Where I remember interviewing CIOs who were kind of, frustrated because they could not explain even to their board why AI was so important. We can skip that step now, right? Now we have kind of the other problem, like like slow down, right? It's not going to be that easy. I remember a question from an investor saying, I want to do medical image analysis. How hard can it be? You just take a foundation model and it's almost done, like half a day. Like why is this thing not finished yet? So people have crazy expectations in terms of maybe workforce reduction. Think about developers. Okay, you have developers in your team. They are using Copilot, I'm assuming, to help them develop code. Are they now twice as productive? Probably not yet. Okay, because development as a profession is so much more than even writing lines of code. It's thinking about the problem, it's decomposing the problem, it's understanding, it's seeing relationships, and then it's translating that into software and components and classes. And so there's so much going on in software development that the coding part is a small thing there, where we see first signs of, we can accelerate this coding part. It's great. But now we have people running around everywhere saying, tomorrow we don't need coders anymore, right? Because it will, the client will basically type in ChatGPT the software he wants. I want an ERP system with doing transport logistics globally, and you push the button and 5 minutes later you have your software rolled out. It's not like that, okay? It's complex still, and we're making progress, but not as quickly as that.
Yeah. So what you're saying is that there might be some inflated expectations.
For sure, absolutely.
Yeah. If you say inflated expectations, that's because you mean it won't materialize that fast. So it will happen. It will happen, but it will take longer. What's the time frame that you see that we see new breakthroughs?
Yeah. So one of the things me and many other people point out that even in GPT-4 there are problems with reasoning, with thinking about the world. The question is, does GPT-4 have a world model? Does it understand relationships between things and objects and how they relate to each other? I don't think so. I don't think it understands. It goes back into its big data set and statistically finds something that is similar, brings it back, and that's your answer to your prompt. We have all reason to believe that it doesn't really understand, because some questions you can ask to the system where it doesn't understand what is cause and effect, or what relationship between objects is, where it doesn't understand that my daughter is called Elke. If Elke is my daughter and that's in the data set, then the thing doesn't understand the reverse, that I am her father. And so from that we understand that it is not reasoning. And so I think that the large language models, with all the benefits that they have, right, and with all the things we can do, which is, by the way, fantastic and useful, don't get me wrong, very useful, we can do many things, reasoning is not yet there. And that leads to how much can you use it for real planning. Can I do transport planning tomorrow with my large language model? Okay, I don't think so. And by the way, the bigger point is, it will not be possible even with a large language model, because in the fundamentals of that model, these things are not possible. And so then, if we believe that...
Why do you say that?
Because it's still next token prediction, okay?
But that doesn't mean it's not capable of using its internal knowledge to detect something. That's not a dichotomy. It's basically what we do. We also next words, and you don't know perfectly yet what you're going to say while you're saying it, but you're reasoning along the way.
Yeah, but we have, some people think, in our brain we have this. We think with symbols. Okay, we go back to symbolic AI from the beginning, and we know about relationships between symbols. And if the large language model does not have that, then by definition it cannot reason on these symbols.
And why wouldn't it? So the thing is, why I find it very interesting to dive into, because I'm at the other side of, I think it will go faster actually. It might actually go quite a lot faster than what we expect, simply because there's a lot of things coming together. We have the large language models, we have multimodality, which is happening, we have robotics, having AI models being learning from reality.
Yeah.
So there's a lot of, all of these things are coming together and they're going very fast. Almost all the money in the world is going to these things. The compute is increasing still, and there's no reason to think that it won't go the same route as in improvements. I think we've just seen the tip of the iceberg, and in the next few years, a lot of new things will happen. And to the point of symbolic, I'm not an expert nor in symbolic AI, nor in human brains. Doesn't matter, but it does matter. So it's just an intuition. I'm not an expert.
Yeah.
But the moment, what we see is already, if they make the model bigger, basic reasoning improves. On problem, you see in tests that it improves, maybe not in the way that you're saying that it's really reasoning as a human.
Yeah, I think it improves because the data set was bigger. So
potentially. But if you look at Phi 2 from Microsoft, which is a lot smaller actually, but well curated data, it's not big, but it has similar reasoning capabilities as GPT-3. I think it's not comparable to GPT-4. But my point is, if you have, now it's mainly language, but we go to multimodality, meaning we add other sources of data. For instance, images, which we know that models break down into components. If you link those two, why wouldn't it not be possible to link that to concepts? Because that's the symbolic thing. Why wouldn't that happen? And why wouldn't that happen? It's a question, I don't know. But next to it, I also find it very interesting, the discussion on, does it have to be working as a human? Is that what we want? Or is it what the output, if the output is economically as what we would do in that same process, it's good enough. It doesn't have to work in the same way.
No, it's true. It does, but the human brain is the best example for the moment. So it's still a reference. Good for us. We're still the reference on thinking and brain power. I like a lot the robotics because it's bringing embodiment. And one of the ideas about intelligence is that you need experience in the world to achieve that.
Learning from reality.
Learning and interacting with the world is what we do from childhood, of course. We experiment, and so this is very promising, I think. I do still think that we need some breakthrough in the way neural networks are structured. Transformers was a big breakthrough, so I'm very curious to see what's after Transformers, or how maybe it's combined with other things to fill that gap. I know IBM was working a lot on neurosymbolic, so bringing these worlds together, everything we learned in the past with what we know now. And for example, simple things. If we agree that gravity exists, then why would we, have a large language model discover that? We could just tell it. And so some AIs benefit from giving it a little bit of real world symbolic knowledge, because they become just so much more accurate. That's
true, but at the same time, isn't it, again, not an expert, but isn't it true that we can't still explain really well why gravity is gravity?
No, Davio, I don't know, but yeah, sure.
But putting that in as a rule,
but why not? So it's like seems to work very well for physics.
Yeah, but that's for me the promise just of the way we're moving forward, is that adding the different types of data, adding the fact that it can move around in the world, it can help us prove answers to these things.
Yeah,
and if you already put rules into it, it's starting from an assumption, which is basically something that we might actually not have to do, and really understand things a lot deeper. That's what I think is that's what I hope. Maybe it's more a hope than think that will happen.
So I agree with you on the hope. So I fully am.
But you don't think that for now, with this technology, it will happen?
I think scaling will not be enough. I think we need a paradigm shift, and we don't know when that will happen. So as you say, there's a lot of money going to this. The brightest people in the planet are working on that. So I mean, if we can find it, it would be fantastic. And I'm optimistic that we will find it. I'm just not sure we can just linearly extrapolate and say GPT-4 was better than 3 and 5 will be at least 10 times better, and then again 10 times. And so if you just, that's simplistic. It will be more complex than that. It will take more time than that. But for me, the good news is, with what we have today, we can do so many fantastic things, even if evolution would stop, and it will not.
But I really think that it will go. Looking at Claude 3, it's not immensely different than GPT-4 in its basics. Even on the numbers that the benchmarks are, it's not a huge difference. Mm-hmm. But you do see that it's already quite a lot more powerful in certain use cases.
Yeah.
So I'm on there's these camps these days, like extreme accelerists or all of these kinds of things. Not necessarily in one of those buckets, but I do think it will go a lot faster than we anticipate right now.
Yeah, the question is
let's agree maybe if I'm now part of the inflated expectations, in 5 years you can come back to me and I'll buy you a dinner.
I hope I'm wrong, but the point I want to make is, if I think about company strategy and where do you bet, like, do you bet that this will happen?
Yeah.
Or do you today say, let's work what is there, see the path where this is going? We can safely assume that GPT-5 will be better than 4, but I don't expect a paradigm shift. I expect somewhat better. And let's work with that as an assumption to make investment decisions and to decide what we do. But that's my concern, right? If you go all the way into inflated expectations, then you could start building companies and projects within companies that already assume that this will be there, and then we might be throwing away a lot of money. So let's not do that. And just this pragmatic coming back from philosophy into the real world, and how do I make money with my company? It's another discussion.
Yeah, but I think that's true. And I think I completely agree. I do think there's two things which companies can do to combine those two views. One, I think it's the reason why I keep on telling it is because I do still see companies doubting, or not doubting. They all want to know about AI and do something, but not all of them really want to do it. It's like, we should have a look at it. And I think that's
wrong.
That's wrong.
Totally.
So that's why I'm pushing for it. That's one.
Totally. Yeah.
They need to start experimenting and learning, because that's the only way that they'll be able to master it. And two, I actually do think, if you look at it from a conceptual view, that you see it as virtual twins of the people that you have. So every role in the company has a co-pilot that has access to the data that they have and supports them in their role. So you actually, if you have this role, you have the similar role in the digital twin, having access to the same data, that you can already extract value from that. But along the way, if it improves and it really becomes a lot smarter, they're already in the right position. It's just you swap the back end basically, and they do the same thing, but they can do it better.
And
they're
a bit more
autonomous,
and
more complex tasks.
Of course.
But it's you can bridge those two gaps in that way.
Yes.
But the fundamental thing is, you need to start today.
That is for sure. And it's also become much easier to start.
Yeah. Now, companies need to start, but a lot of them are, and society at large, I would say, they're still thinking of, will this go south, or will we go to a dystopian future or a utopian future? What are yours? What's your dystopian future?
So my dystopian future is one where AI increases inequality, and we don't need super intelligence for that. We just need uncontrolled use of that. And it brings me a little bit back to, like, how much control do you put as a society or in Europe on your AI systems? We want a society in which people are equal, get at least equal opportunity to be successful. And so we need to do that, I think. That's why that is very, very important. And this is a real problem today. It's real. Fake news is real. The being able to have a convincing video of a person saying things when they never said those things is scary. right? And inequality leads to a lot of problems in general, unrest in the world. And so that is for me dystopian. AI systems, even the ones we have today, being used in the wrong way for discrimination, for automatic CV scanning that just picks out white rich people to have the jobs if we don't control how these systems are built. This is not. This is real. This is already happening. Dystopian is not for me evil robots or paperclip making machines.
You're not scared of
I
that?
don't believe that. I think we are far away from that, from consciousness, from the famous singularity. Kurzweil just this week said that within 5 years everybody will become 150 years or something old. Okay. Some people are, that's nice for philosophers, but I don't believe it. So we need 25 breakthroughs to get there. So I'm not worried about that. I'm much more positive, actually, on the positive side. The things we are able to do that were simply impossible, because all this power is now accessible to creative people that, for example, work in healthcare and that can imagine breakthroughs in, for example, rare diseases. People that are suffering from diseases for which the pharma companies today, they cannot have any attention for those people because there's maybe only 3,000 people on the planet with that disease, so it's commercially not interesting, it's too much risk. We saw even novel drugs being stopped during COVID because, investment, climate changed, and so this is a disaster for some people. So if we can automate those things, do automated at-scale drug testing in a virtual body, for example, using AI, I mean, the things we will be able to do, it's just so crazy. All the challenges in finding better batteries, finding more efficient, harnessing the natural energy of the sun, of wind, of waves, of all these things we will lead to breakthroughs just because of the power of the AI systems. That makes me very positive about the technology, because we need those things, because there's too many challenges and not enough people, and so the AI will just totally help us with that. If we can avoid the other, like the challenges there, but on the plus side, there's so much to be done.
And how do you prepare for it? How do you, or your family, how do you do anything in particular right now, or you let it come, or?
So I'm in the middle of this, right, Davio? I think about this every day. I work with this every day. So I'm not like a typical user, I think. For example, my son, he is studying game development, doing hardcore C++ programming. And so some people say we will not need any programmers anymore. I disagree. And I think, again, as in many professions, it will be the people that are able to best use the AI that will be successful, that accelerate their own abilities. So we need to. So he has to be aware of all these new options, possibilities to help programmers. But at the same time, the phase that he is in his learning, I think he needs to learn the basics now first without AI.
Okay. So he can be skeptical or
not skeptical, because he will be much better able to direct the AI to do what he wants if he exactly knows what he wants the thing to do. So the whole decomposition, the real art of making software, the engineering of making software, it helps if you've been hands-on with many things. I'm the same way. I need to test stuff to see what it really does. I don't believe the marketing. Let's try it. Let's see. Let's understand how it works, because then we can best use it. We don't go in the hype. We don't go into the negativism, but we use it for what it can actually do. So for me, it's important for him to be aware of these things, first do his studies, and then be very, very good at using the power to accelerate.
So actually what you're saying is that we still need to be experts in something, and that will then using AI to accelerate us.
Yeah, I think so. Being an expert in something is really valuable.
Yeah. And still will be in the future.
Yeah, I think so. Yeah.
All right. On that note, thank you, Wouter.
You're welcome, Davio. It was a
very,
pleasure.
very interesting. Thanks. Thank you for listening. If you want to hear more, don't hesitate to subscribe on your favorite podcast platform for the next episodes of Future Forward, where we'll be unraveling the AI future, one expert at a time.